Now, let's quickly go through how an edge detection algorithm can be evaluated, because we want to automate this. So far, we are just talking about by just visual inspection. Okay, this edge detection seems good, this is not good, but we should have like a computational way or like a quantitative metric to compute how good our edges are. So we'll briefly talk about that. And this again, you might, if you have taken machine learning course or any statistics course, you might know like what recall is, what precision is. So we'll quickly go over this. Now, let's say this circle over here represents all the edges, which your method is actually saying are edges. All right, so this is kind of results from your method. The red one is, let's say, the ground truth. So this is the set of actual edges. So if you will quickly look at this, you can see that you are saying all these are edges. But again, this is at a conceptual level, I mean, we don't have any edges here, right? So this is just like the set of edges we have. So this is the area where we are saying there are edges, but they were actually not ground truth. And the center one is like the edges, which were actually edges, and our method also said like it's edges. And these are all the edges, which were actually edges, but our method actually was not able to recognize these as edges. Okay, so we have terms for all these. The center one we call true positive because our method said it's an edge and it was actually an edge. Okay, so that's true positive. Then true negative, all these were not edges. These are like outside your red circle, right? And our method also said these are not edges. So these are negatives, but true negatives. Then the next one is false positive. So false positive, this region where our method said these are edges, but these were not actually edges because these are like outside the red circle, right? So we call them false positive because our method is saying these are positive, but actually these are not positive. So false positive, okay? And last one is false negative, which again, it's the same scenario as false positive. So our method said these are negative because we don't recognize these are edges, but these were actually edges because these are inside the red circle. So we call these false negatives. So once you understand like all these terms, you can easily compute precision and recall. And these are the formula. I will just give you the intuition. We'll not go over the equation. You might know already know this. So precision is how correct your method is. All right. So if your method is saying something is an edge, so is that correct or not? So that tells you about precision. All right. And that's exactly what is being shown here. True positive over the results of method. Right. So for example, your method said 100 of these were edges, right? So that's the result, but actually only 50 of them were edges. So that will be true positive. So then your precision will be 0.5, or you can say 50%. Okay, so it's about like what your method is saying and how much of that is correct. That's precision. Recall is slightly different. Recall tells you if there were, let's say, 1,000 edges, then out of those 1,000 edges, how many of edges your method was able to detect, right? So it's, you can see like it's kind of recalling what is an edge and what is not an edge. So if you look at this formula over here, it says true positive over ground truth. All right. So let's say the ground truth, you had 1,000 edges. All right. And true positive, your method only could detect 50 edges which were correct, which means that out of 1,000, your method only predicted 50 edges. So the recall will be 50 over 1,000, just 5%. Okay, so that's like the slight difference between precision and recall. So precision is how accurate your method is, kind of, and recall is like how much of it the method can actually recall or collect. All right.